Once again, if I had wanted to find the derivative of this function, I would have had to multiply out the two brackets, got terms, and then I could have used my power rule. And so my function y could have been written as 2x cubed minus 6x plus 2x squared minus 6. Finding the derivative of this function, the derivative's answer is in fact going to be 6x squared plus 4x and then minus 6. All I've done over there is I've written it in a reducing degree of x. Now, had you maybe been tempted to try and find the derivative of the first bracket and then times it by the derivative of the second bracket, you would have been, unfortunately, hopelessly wrong, because this answer is not going to be 2x times 2. So if I have a function and it's made up of a product of two functions, I must make sure that I can expand and then use my power rule. But if I'd wanted to expand this function over here, I would have been multiplying out a lot of terms, and the chances of making an error can creep in very quickly. Because mathematicians like to find other ways that they can do things so that they can avoid these silly mistakes, they've developed a new rule. This rule is called the product rule. Now you can see in this case, I have in fact got the product of two functions. The first bracket is my first function, and the second bracket is my second function. If I have a product of two functions, I'm going to show you the next rule so that I can differentiate this function without having to multiply out these brackets. Going back to the example that I had first and highlighting the two functions, I'm going to check and see if my product rule works over here. Now this was a very easy function because, as you know, we were able to multiply out very easily. The product rule says that if I want to find the derivative of this function, then I must do the following. I'm going to do this in blue so that you can see that I'm using a different rule. So dy by dx, when it is a product, says find the derivative of the first function and times that by the second function. And then add that answer to when you find the derivative of the second function and times that by the first original function. So here we go. Finding the derivative of this product of the two functions f of x times by g of x, where f of x is the first bracket and g of x is the second bracket factor. The derivative of f of x is the derivative of x squared minus 3, and we know that that is 2x. Now, using the product rule, that tells me I must take that answer and times it by the function g of x exactly as it was, and g of x was 2x plus 2. Now do it the other way round. Find the derivative of the second function, g of x. The derivative of g of x is going to be 2, and times that by the function of f of x unchanged. The function of f of x was x squared minus 3. At this stage, you can't see that this is the same as what I had when I multiplied out my brackets and I wrote it just in a reducing degree of x once I'd found the derivative. So let's simplify this statement over here and see if it comes out the same. Multiplying out my brackets, the first term comes out as 4x squared plus 4x. The second term is going to be 2x squared minus 6. Well, you should have been able to see by now that this is, once I've written my terms in a reducing degree of x, going to be exactly the same as I had above. 4x squared plus 2x squared is 6x squared. And then I've got plus 4x and minus 6. So what we've done here is we've developed a second rule to find the derivative of a function. And this rule can be used if I've got the product of two functions. Remember the second example that I gave you? That was the one that would have been very complicated if I tried to multiply out those brackets. So let's try practicing using our product rule. To find the derivative of this function over here, I said that you must first find the derivative of the first function and then times that by the second function. Add that answer to the derivative of the second function times by the first function. So treating each bracket as a separate function, I find that the derivative of this function, the function of y, is going to be as follows. The derivative of f of x is going to give me the answer of 3x squared minus 4x and plus 1. Remember, I have to times that by g of x, which is the original function of x cubed minus 4x plus 2. And then I must add that answer to the derivative of g of x, which is going to be 3x squared minus 4, and I times that by the original function for f of x, which was x cubed minus 2x squared plus x and minus 1. You can see why I tell you not to bother to simplify, because if I had tried to simplify this expression, I would have landed up once again multiplying out very complicated brackets, and I might have made a silly mistake. So in other words, the derivative of y is going to be the answer that I've given to you here in this last line.